Okay. I'm live, Anisu. Check. I've changed it to public, okay? Anisu? Check. Can you see? Is it appearing? Okay. So let's talk about it. Remember, I said I'm going to talk about right 20. If I'm writing, we're doing part 1 of space physics, which is the Earth. Everybody, we're starting with part 1. Of course, we have to start with part 1. The Earth and the solar system. And you're not letting me down, okay? There are things that we need to quickly get over, and you guys are not letting me down. So let's quickly get over it. This is not a big chapter. Let's quickly get over the things that you gotta know. Then I'm not doing calculation questions right now. I'm not going to teach you how to do calculations. I'm just going to give you the theory part of things. For calculations, we have a very short way, which we'll do as the last lesson on this topic. Are we together? Students, do you hear me? So, now, do you hear me, everybody? Okay. Part 1. So let's say 1. We're going to do 8 things, okay? Then I'll say you're done with this first section of the solar system and the Earth. So by the time we finish this, we should really understand what we mean by what we should know about the Earth. Okay, when we say what you should know about the Earth, you should know about the rotation of the Earth. You should know about the revolution of the Earth. You should know about how that causes day and night, the rotation. Then you should know about seasons, and you should know about the movement of the sun. Okay, apparent, because the sun doesn't move. So the apparent. Then you should know about the moon and its phases. You should understand it. So that's what I'm going to be going through. Right. First, I'm going to talk about the Earth's rotation. Right. So write with me to say that. Okay, this is the first thing. Write with me to say Earth's rotation. Okay, or I can say the Earth. Maybe I'll say the Earth, the Moon, the Earth, the Moon, and the Sun. Then after this, I'll talk about the solar system. It's all part of the first section. There are 8 things we'll talk about for us to say we are done with everything you should know about the Earth and the solar system. Right. Now, write with me. There are very, very big lines that I'm going to be giving you. Write with me to say the Earth. The Earth rotates on its axis once every 24 hours. So the Earth takes 24 hours to rotate. Okay? Are we together? This rotation by the Earth causes 1, the day and night. So let's just say it causes day and night. Why is it evening right now? Because the Earth is rotating. Do you hear me? Will we have day and night if the Earth is not rotating? Students, are we going to have day and night if the Earth is not rotating? No. The Earth is rotating, which means if the Earth is like this, that means it is going like this. It's rotating, spinning like this. Okay? And we say that the Earth rotates on its axis. It will be spinning around. Axis is going to be a line like this. And you're going to see that the Earth is tilted. So the axis, right, to say the axis of the earth, or the earth's axis, when we say it is rotating around its own axis, the x-axis is a line that comes from North Pole to South Pole. So you can say the earth's axis is a line that passes through North and South Poles. Okay? And South Poles. So, now, I want to write the second thing that is caused by rotation that I had jumped. That is why I skipped the line. It is the daily motion of the sun. Okay? The movement of the sun. That looks like the sun is moving. But the sun doesn't move. The sun can't move. But the apparent movement. Why is it that it looks like the sun is rising, then the sun is setting? This apparent movement of the sun, okay, rising and setting, put in brackets. Say by apparent movement, we mean the rising and setting. From the rising of the sun to the setting of the sun. So rising and setting. This is all caused by the rotation of the earth. It looks like the sun rises and the sun sets. No, it never does. It's just the earth that rotates. The sun will be in one place. So you see that the earth will be like this. This is the axis. Then you have the earth coming like this. Okay? Here's the earth. And it's like this. So this is the axis, of course. This is the axis of the earth. The line that passes through the North and South Pole. And we're saying the earth will be rotating like that. And the sun is in one position, you know. This is the sun. So if this part of the earth is close to the sun or is facing the sun, then that means this is day. And the other side here is night. And the earth keeps rotating so that this side which was in night now will be this side, which means it will be daytime. And then this side which was day will now rotate like this and go to this side, and it will be now night. So the earth is continuously rotating, causing day and night, and causing the apparent motion of the sun. Are we all together? So, rotation of the earth is what? Rotation of the earth is spinning on its own axis. This is what we mean by rotation of the earth. It spins on its own axis. Going round and round, and it's doing it right now. That's why it's evening time. Because we are not facing the sun right now, the earth has rotated us. Okay? Are we together? Then we do the second thing. The earth's revolution. Say now the earth revolves. Skip 2 lines like this. Then now say the earth revolves around the sun. The earth revolves around the sun once every 24 hours? No. Every 365 days. The earth would have gone around the sun. Here is the sun. The earth is like here. Okay. Then it is going to go right round like this. Okay. It will, whilst it's also rotating every day. Okay. It will still be rotating every day like this. And it will still be moving like this around the sun. The sun is in one position whilst the earth is revolving around the sun. And this happens once every 365 days. Does it cause day and night? No. So it doesn't cause day and night. Yes, the earth going around the sun, what does that cause? This causes the revolving of the earth. This causes 1, a year, and then 2, seasons. Seasons. Okay? And I want you to put in bracket to say, so when the earth is going round the sun, that is when we are experiencing different seasons? Yes! Is that why it's winter right now? Yes! Okay? And I want you to say here, the tilt, also the tilt of the earth also causes seasons. So seasons are caused by 2 things. Number 1, it is the revolution of the earth around the sun. The earth going around the sun, it causes seasons. Summer, autumn, winter, spring, the 4 seasons. And also the tilt. So it will be revolving, but as it is revolving, it is tilted. So it is tilted like this as the earth is revolving. It is revolving, but it's tilted. It's not upright. When it's like this, the earth is tilted, like this. Huh? The earth is tilted when it's revolving. It's tilted. And now what you will see is that this part which is at the bottom, this part is now close to the sun when the earth is here. But this part which is at the top at once was the one which was close to the sun. So it was having summer. This side was summer. The top part of the earth was summer. And this was winter. But now when it gets here, this part is now summer, the bottom part of the earth, and the top is now winter. So these seasons are being caused by the revolution. The earth is going round. When we say revolution, what do we mean? When we say rotation, we mean it's spinning around its own axis. It's just going. When we say revolution, we mean it's moving around the sun. To revolve is to move around another object. You are not rotating just in one position, but you are moving around some object, which in this case is the sun. So the earth revolves, which means to revolve is to move around another object. So the earth revolves around the sun once every 365 days, causing what? Causing the years, not day and night, but it causes years. Oh, now we are in 2026. The earth has gone around. It's done. That's why we are now in 2026. And the other thing that it causes is the seasons. Summer, autumn, winter, spring. Are we together? Are we together? So we now know about the earth's rotation, and we now know about the earth's revolution. Now, what about the earth's tilt? Skip 2 lines and write after 2 lines. Right? The earth. The earth's axis, which is the line that joins the north and the south pole together. That line, so the earth's axis is tilted. Okay? Is tilted at 23.5 degrees. Are we together? Hello? 23.5 degrees. I want you to say from the vertical. So if we are to show our planet Earth like this, and we are to show things like this, and we are to take a line and we cross it around like this, then what we are going to have, this is the axis. This is the axis of the earth. It's slanted like this. This would be the North Pole. This would be the South Pole. But the true vertical line is not there. The true vertical line is this one. And what we do know is that this angle here is 23.5 between them. Okay? It's 23.5. Are we together? Which is also this 23.5. So the earth is tilted. Oh my goodness. Oh my days. Yes. Okay? This axis, this is the earth's axis. Okay? And then this is the vertical. and there's a 23.5-degree angle. Okay, we are not discussing. We are telling you. Hey. Okay. So the equator of the earth is actually not flat like this. Although it cuts the earth into half, it's slanted. Because your earth is slanted. And this is going to be the northern hemisphere. The upper half. This is the northern hemisphere. We are in the southern hemisphere. All of us, the bottom half of the earth. Botswana, Zim, SA. This is the equator. Are we together? So the earth is tilted, sir? Yes. So as the sun is coming, it doesn't hit all past the same. No, the sun's rays will come like this. This side which is tilted towards the sun is the one which is experiencing day. So there is day this side. Okay, there is day. Then this side there is night. So day is like nicely somewhere through the half here. It's like this side. This side of the axis which is tilted towards the sun is in day. This is day. Then the other side, let me choose it to be blue. This other side is night. The red part is day, the other part is the night. Because the earth is tilted. So the part which is tilted towards the sun is getting nice rays. It's daytime. Then the other part is nighttime. Okay? Now, the tilt of the earth. This tilt causes seasons, okay? The 4 seasons, okay? It causes the 4 seasons to happen. Summer, autumn, winter, spring. As the earth is revolving around the sun. So, seasons are caused by revolving, going around the sun, and being tilted as you're doing it. Because at some point, the side is the one which is closer to the sun. So it's in summer. At some point, when the earth is here, like this, and it's still tilted, and it's like this, then this part is now closer to the sun. Then at some point, the earth is still tilted. Now the bottom is now closer to the sun. So you see, it's different parts that are closer to the sun at different points. So that's when we have the summer, the autumn, the winter, whatever. Are we together? So you can go to this country right now, whilst we're in winter. They're having nice summer. Yeah. In Europe, they're enjoying their summer. In USA, they're enjoying the summer. Are we together? So the tilt also causes the 4 seasons. Then number 2, it causes different temperatures. The earth has different temperatures. Of course, this is from seasons as well. It's caused by the tilt. Okay? And it causes what? 3, it causes different daylight hours. Different daylight hours. If you go to USA, okay, I know people there. The sun sets late, much later, I think around 9 or 10. In Norway, you can have days where it's in the evening, it's around 10 or 9 or whatever, and the sun is out. You're like, what? 10 p.m., the sun is still out? Come on now. Yes. So they don't have the same daylight hours as Africa. It's because of the tilt. Are we together? Okay. Is everybody okay? Are we together? So tell me the two things that cause the Earth's tilt. Two things that cause the 4 seasons. Number one. Hello? Tell me the two things that causes the 4 seasons. The tilt of the Earth. And number two, the orbiting of the Earth around the sun, or the revolving of the Earth around the sun. This word revolve, which we are doing, can also be to orbit. So you can also, it can be exchanged by the word orbit. Okay, and this happens once every 365 days. But day and night happens once every 24 hours. And the side that faces the sun is experiencing day, and the side which is not facing the sun is experiencing night time right now. So we are on the other side here. But we know that the Earth is rotating. So by morning, we will be now facing the sun. And the Earth will still be revolving to give us winters and whatever. But it will be also giving us day and night, day and night. But it will be also giving us seasons. Summer, autumn, winter, spring. Are we together? Okay. Now, there's the second thing which I want to do, but I feel like it may take us some time. I'm fighting with myself right now to say, should I do it? Should I do it? Should I not? Should I do it? Yes, I see some hand is up. Does the Earth do what? It moves like this. Answer. I don't know. You check. Yeah, moves like this. The Earth moves like this. Answer. Yes. But all you have to say is that it revolves around the sun. Don't be specific like that. Okay? Just make sure you say the Earth revolves around the sun. Are we together? Right. Now, next thing is we want to talk about, we're still doing this, but we want to talk about equinoxes and solstices. Okay? So can you write this word? Equinox. And I want you to know, okay? Meaning, equinox, and say, I want you to say, this means, when you have an equinox, this means you have equal day and equal night. Has everybody ever seen that? The sun rises late and it sets very early in the winter. When it's summertime, when it's 5 o'clock, the sun is already out. You can already see outside. You can go outside. During winter time, it's dark. And then when it's 5 p.m. as well, you can still move around 6 p.m. But in winter time, it's already getting dark. So that means the day is very short. It rises late, it sets early. So in winter, the day is very short. In summer, the day is larger. Okay? Now, when we now have a point where we have equal day and equal night, then we say we have an equinox. Do you hear me? And I want you to say this occurs around March 20, okay? It occurs in March and September. March 20 and September 23. I want you to know that these special days we'll be doing are in the 20s, all of them. Okay, some 21s, but it's still 20s. Are we together? So when we have equal day and equal night, we say we have a what? An equinox. Equal day and equal night. Now, what about a solstice? When we say we have a solstice, it means they are not the same. When we have a solstice, it means Either the day is longer or the night is longer. And I want you to know that when we say summer solstice, this is the longest day, which means day is very long, night is short. Then winter solstice, it's not solstice, solstice. 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 This is the shortest day. Are we together? So if we're experiencing winter solstice, we're experiencing the shortest day. Are we together, students? Okay. So right. Let's go here. Here's the reason. One of the hemispheres, we have northern and southern. One of the hemispheres receives max sunlight, whilst the other receives minimum sunlight, making it the shortest day. Minimum sunlight. Are we together? Okay. Now, let me just give you a background on this. Okay? Let me just give you a background on the solstices. Right? You want to write? Write here to say the southern and the northern hemisphere, because this is where a lot of people get confused. Southern, okay. Obviously, if we are saying that solstice, the days are not equal, okay, we're saying either you have the longest day or the shortest day. This is caused by difference in sunlight, okay? Either you're going to receive minimum sunlight or maximum sunlight. But when you have the day and night being equal, it means both hemispheres are receiving the equal level. Both hemispheres, the sun is shared equally, receive equal amount or equal sunlight. So you are having the 50-50%, okay, 50 each 50. So that means that's a perfect situation. You have equal day, equal night. The same 12 hours daytime, 12 hours nighttime. That's an equinox. Here, solstice, no, my friend. That's not like that. They are not equal, the day and night. In an equinox, they are equal or nearly equal. For a solstice, they are not even. Now, for southern hemisphere, when do we have certain things? Southern hemisphere is Botswana, Zim, okay? Are we together? So things that are happening to us are happening in the southern hemisphere. Let me also include Let me also include Zambia for Alex. Can you see? Now these are all southern hemisphere. Okay? USA, UK, China, northern hemisphere. Now, what I want you to know is that you are going to have the same date, but you're going to be in opposite seasons, which means you're going to be in opposite equinoxes or in opposite solstices. Okay? Give me a second. I'm coming. Give me 1 second. Okay, can you still hear me? Everybody? Okay. Nice. I'm happy that you can still hear me. All right, let me just here's the thing. Let me give you so that you understand the dates, right? We'll start with the southern hemisphere, and then of course we'll talk about the northern hemisphere. How this happens, right? Hello, people. Right. If you're in the southern hemisphere, then you have days. I want you to know 4 important days in your calendar. There's going to be, it's not usually exact, but it's around 20 March, okay? Then June, okay? It's like 3 months, 3 months, 3 months. Then September, and then December. These are 4 important days. The first 3 months, then 6 months, then 9 months, then 12 months. So it's like it's divided into quarters. 3 months, 3 months, 3 months. 20 March, 21 June, 23, 21. So 20, 21, 23, 21. Are you seeing? Now, what you're going to have on 20 March here, you are going to have what we call an equinox, but it will be in autumn. So it's called the autumn equinox. And after 9 months, you're going to have what we call the spring equinox. And when we have equinox, it means that the southern and the northern are experiencing the same amount of sunlight. Right? Right. Good. And that is when the earth is above or below the sun. So you'll be having the sun, and you have the earth here, and you have the earth down here. I want you to know that these are times for equinoxes. This happens in March, and this happens in September. Are we together? Then when there is unfair distribution is here, where you have the solstices, okay, and here. The earth will never change how it's tilted. It will be always tilted like this. Can you tell me the angle? What is the angle of the earth's tilt, everybody? 23.5. 23.5. Well done. So now, what happens is we have an equinox and an equinox, which means we have day and night almost equal, right? Or equal. Are we together? In March and in September. Okay? Did you understand that? Now, in June, of course, we are in winter. So we have what we call winter solstice. And everybody knows that you have the shortest day. When it's winter solstice, you have the shortest day and you have the longest night on 21 June, around that day. Now, when we are in 2021 December, we have the summer solstice. We have summer in December. You know that for these Southern African countries and all these countries in Southern Hemisphere. You have the longest day and shortest night. Do you understand this, students? Now, it's going to be exactly the same for Northern Hemisphere, but what is going to be changing is you spin around the solstices, even the equinoxes. You spin around their names, but we know that it will still be the same. So it will be now 21 June is their summer solstice because they have summer in June. Right now, it's summer right now in England and in America and in China. Then they have their winter solstice in June. Do you understand? In December, rather. That's when they have their winter. Do you understand that? So for northern hemisphere, you flip it around. You swap the equinoxes and you swap the solstices. Okay? You swap them. This solstice is here, this one is there. Then you swap the equinoxes, and then you have the same thing for northern hemisphere. Huh? You can do it for northern hemisphere. Just swap the equinoxes. This becomes spring equinox, and the other one becomes autumn equinox. But it just means the day and night is almost the same. Then here we have summer solstice. Then here we have winter solstice in June, and you're done. So we start with autumn in southern hemisphere, but in UK and stuff they start with spring equinox. Is everybody fine now? All right. Last thing. So I wanted you to know equinoxes and solstices. Then last thing, the phases of the moon. September, March, June, and December. So it is March, June, September, December. 3 months, every 3 months. 3, 3, 3, 3. Phases of the moon is the last thing. Phases of the moon. Okay, I don't know where I'll get to on this. We'll try. We'll see how much I can cover. But when you talk about the phases of the moon, now everybody, I want to get some things out there. Okay, the material that makes the moon makes it reflect light. So all the light, okay, some of the light, or the light that hits the moon, what is it going to do? When light hits the moon, what do you expect it to do, class? Hello? What do you expect the light to do? Pardon? What do you expect the light to do when it hits the moon? We expect it to reflect that light. Huh? Are we together? So if you have, here's how it goes. The sun. Okay, before I talk about the phase, I just want to get certain things. Here is the sun. When you are seeing, this is the sun, and this is the earth. When you are, and we know that the earth is actually traveling. When you see the moon, it's not when it's here. The moon actually is a small thing, which on its own, it actually goes around the earth. So the moon itself is actually going around the earth right now. Do you understand? Now, when you see the moon, it's not when it's here. When the moon is here, you can't see anything, because the sun's rays hit it and go back. So this is called a new moon. You are not seeing nothing. You look up in the skies, nothing. Like right now. Go and check outside. Can you see any moon today? Can you see any moon, students? Hello? Can you see any moon? There is no moon. Right. Oh, really? Yes. So there is no moon right now? Yes. Now, when it is here, you are seeing the whole of it. It's called full moon. The sun will be hitting and reflecting back on the earth. Then you'll be seeing, oh, look at that moon. Yes, it's reflecting. It will be on the other side of the sun. Don't you think it is here? No, moon doesn't let light through. So don't be naive. New moon is here, which means you are seeing nothing. Full moon is on this side, which means you're seeing the whole thing. Now, what then happens? So here we have the full moon, the whole thing. Here we have nothing. So that means from nothing to full moon, it should be increasing. Then from full moon, it goes back to nothing. It should be decreasing. So this part here, where the moon is getting bigger, we call it the waxing stage. It's getting bigger from nothing, from a new moon, which is nothing. You can't see any moon at all. Then it starts to get bigger and bigger. It's waxing until it gets to the full moon. Then it goes from full moon, it starts what we call waning. It starts waning, which means it starts reducing, going back to new moon, which is going back to nothing. When it's here, this is when you see half moon, and we call it a quarter moon. Why do we say quarter moon? Because it's the quarter of the stages. Okay? This is new moon, then you have the quarter, then you have full moon, then you have another quarter. Here you see a quarter again, like this. You'll be seeing half moon, but we call it quarter moon. So we call it the first quarter, then the third quarter. So this is the last quarter. You can write it to say last quarter moon. Then here is the first quarter moon. Okay? It is half, but it is increasing. So it is half, but is increasing. When it goes above half, when the moon is above half, we don't know, is it growing or is it growing larger, which means is it waxing, or is it going smaller, which means is it waning? Now, it could be above half, which means it's at this part here, and it's growing. This is waxing. And I want you to know right now that when the moon is above half, we call it a gibbous moon. So you have a moon which you can see, this is the moon. You can see more than half of it. Okay? You can see more than half of the moon like this. Then this other one you can't see. Why? Why are we seeing more than half? This is because it's growing. It has passed the first quarter. So now it's more than half. So it's a gibbous moon. A gibbous moon is when you can see more than half. From here to first quarter, you can't see more than half. Okay? Let me erase like this. So we call it a crescent. Crescent or crescent moon. Like this. Where you are seeing only a small part like this. In blue. This is what you'll be seeing in blue. This other part in white, you can't see it. We call it a crescent moon. Right? Crescent moon. And here it would be waxing crescent. Then here it will be waxing gibbous moon. In other words, it's gibbous, it's above half, and it's waxing, it's growing until it gets to full moon. Then when it starts to come like this, it's now waning. And when it's still above half here, we say it is a waning gibbous moon. Are we together? We now have a waning gibbous moon. Then when it's like this, when you can now only see a crescent, like, it looks like this. When you actually look at it, it'll be looking just like this. This is now called a waning crescent. It's a crescent, but it's actually getting smaller until it will be nothing. So crescent could be waxing, growing bigger, or waning, growing smaller. Okay? This last quarter is a half moon. This is a half moon. You can call it a half moon. And here, this first quarter moon, you can also call it a half moon. Are we together? So we have new moon, then crescent, then half moon, then gibbous, then full moon, then back to gibbous, then half moon, then back to crescent, then nothing, which is new moon. Do you understand? Now, this cycle of growing, don't let me down. So if we have a crescent, which means a tiny moon, it could be growing, it could be in waxing stage, or it could be waning. You should know that. If we have a gibbous moon, it could be growing or it could be waning. It could be waxing or waning. You should know. Are we together? Students, here it's when you see your moon looking like this, tiny, yeah? Here it's when you see a big moon like this, almost a full moon. when you see a moon like this, almost a full moon, that's a gibbous moon, and it could be waxing like this. All right. Are we together? Now, right to say, this cycle of the moon takes 28 days. Sometimes you see them say 29 days. So you can say the moon is going around the sun, is going around the earth, is a natural satellite. Okay? It's something that goes around the earth. It's a natural satellite. Okay? And I want you to say it orbits the earth. It orbits the earth in about 28 days. And it also rotates once every 28 days. Which means the same side always faces the earth. Okay? The moon does not produce its own sunlight. It just reflects sunlight. Just reflects the sunlight. Okay? Sunlight. It reflects sunlight. Yes. Oh, it does not produce its own light. Well done. It just reflects sunlight. Well done. The order of the moon: new moon, waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, last quarter, waning crescent, new moon. Right? We know that. The cycles of the moon. Here, it's blocking the sun. We are seeing absolutely nothing. Then you're going to see this. This is a crescent. Then it gets to half. Which is the first quarter. Then it gets to be more than half. This is going to be waxing gibbous. Then you now see the whole moon. Okay, so here you are seeing nothing. Here you now see the whole moon. Then here you see again a big portion. It's now waning gibbous. Then you're going to see a half moon, which we call it the third quarter. Then you see a crescent. Then you have new moon. Excuse me, so what's shaded is what you see. And the cycle will restart. Okay? This is day 0. And the moon is not visible. Day 0, moon not visible. Okay? This is the earth here in between. So the moon is not visible at day 0. Okay? Why? It is between earth and sun. Okay? Moon not visible. It is between. This is the sun. Earth and sun. Then here, you say day 7. Okay? I want you to know. Okay, but this actually is day 7. Then this becomes day 14. Then this becomes day 21. Then day 28 is here, just before day 0. Day 0 is like day 29. The 29th day, we have restarted the cycle. So the cycle ends at day 28. At day 29, you are back to 0. So this is like day 29. We have restarted again. Cycle restarts. The moon is not visible. Here at day 7, half moon, half of the moon is visible. So after 7 days, we see half of the moon. After 14 days, we are going to see full moon visible. So if today there is nothing, check after 7 days. This day next week, you should see half moon, half of the moon. Okay? And we call it the first quarter. So this is the first quarter. Okay, after 7 days. From tomorrow all the way till next week, you should be beginning to see this crescent growing until it's half moon. Then it will pass and get here, give us until it's full moon after 2 weeks. Then it will start getting smaller again. Then at day 21, we are back at half moon, okay, which is the third quarter. And then at day 27, where we can see nothing. This is half moon visible, okay? Half moon is visible. Not necessarily that it's called half moon. It's called the last quarter. So you say, wow, we're watching the last quarter. Okay, then it goes like that. Are we together? Don't let me down. Starting tomorrow, we start to look at the solar system. We look at the 8 planets. After we talk about the 8 planets, then we'll talk about the other parts that are orbiting. We'll talk about the things that you find in the solar system. The sun, the 8 planets, the moon, the asteroid, the comet. We'll talk about it. Then the artificial or man-made satellites. Okay? Like there's a man-made satellite which always goes around us, which is called the International Space Station. You can research more about it. Well, we'll talk more about this all tomorrow. Finish it, see how much we can get to. But do not forget, don't let me down. This from here all the way to there is the waxing stage. So this is a crescent, we know, because it's less than half. It's called waxing crescent. This is first quarter. This is waxing gibbous. This is full moon. This is now the waning. This is the waxing stage. This is now the waning stage. It's now getting old. So this is waning gibbous. This is third quarter. This is waning crescent because it's a crescent. So you should know, oh, that's a crescent moon, but we should know, is it a waxing one or a waning one? You check with the cycles, and that's how you master it. Does anybody have a question here? Is there anyone with a question? Students? Okay. We meet tomorrow. We'll continue with this. Have a good night. Make sure everybody has submitted my maths. And let me just take the attendance of these good ones that have finished the lesson. These good students. Okay, I'll send the questions to do with this that I've done. I'll send as a PDF in the next few minutes, and we'll see how much. Then I'll make sure those 6 documents that I've sent have arrived, and then we can continue. That's how I make sure that everybody's going to have to watch this, okay? Because there's no running away. We just are going to do even more. So we have much more work. We'll continue tomorrow. We are going to try. We'll see by the time the day ends how much we would have done of this chapter, right? Are we together? All right. Okay, good. Goodbye, everybody. We'll meet tomorrow. 10. Okay, Anthony, 10 in the morning. Bye.